Let's now come back to climate, but try to look at regional climate. It's not always easy because the evidences in ice cores, sediments, and so on can be global averages, even though, of course, some Antarctic ice sheets and Greenland ice sheets can have local signals, as we saw with the bipolar seesaw. So going back just for fun to the long time scales, here we are going back to 65 million years ago with our Paleocene-Eocene thermal maximum, early Oligocene cooling, late Oligocene warming, mid-Miocene climate optimum, which remained fairly flat here, and coming more into the Quaternary cooling and zooming into that last 3 million years ago, where we begin to get into the archaic human timescales and changes in East African climate, East African acidification, and so on. And you can see now the 100,000 year kilo-year world, where the last million years had a bunch of ice ages at 100,000 year time scale, whereas before that we had the obliquity time scale of 40 kilo-year in the records. And if you zoom in further to 60,000 years, we already looked at marine isotope stages, and we can add some details in terms of millennial climate variations that we talked about, where there is robust evidence from it from various places, but no accepted theory exists for what causes them. There are events like Bowling-Ailerod, which are abrupt climate changes, which are very relevant for modern climate change because we are doing global warming, and especially coming out of here. I mentioned Younger Dryas already, but you can see it more clearly in this record that goes 60,000 years, where the last glaciation had ended around 21,000. It peaked around 21,000 years ago, and we were getting this is, you have to be careful with the time scale, so 10,000 years is here, so this was 11 to 12,000 years ago. We were warming, temperature increasing, and then we will see a little bit later on when we come to the end of the glaciation that there was presumably meltwater locked up behind the ice bridge in Lake Agassiz, which burst and released a lot of fresh water onto the Deepwater Formation site, which created a retreat to cooling. So you can see that cooling happening here. That is again very abrupt, and then we jumped out of it again and got into the Holocene with a little blip like 8 kilo-year cooling, and we'll come back to this in more details later on. If you zoom in a little bit more into the last 16,000 years, you can see the Ailerod warm, Younger Dryas cool period, more clearly the 8.2 kilo-year cooling. You also begin to see the medieval warming, Little Ice Age, and the contemporary warming here. So during the same time you can compare to Pleistocene glaciations in the southern hemisphere, so you can see how they compare. So you always have to keep the hemispheric contrasts in mind as well, that most of the evidence is heavily biased by being from the northern hemisphere. Okay, so emergence of modern anatomical traits in Africa, emergence of Neanderthal traits in Eurasia, or in this record going back to again 100,000 years. So we are looking at a few more details with the marine isotope stages, and we are looking at forcing from various orbital parameters. So insolation at 65 north. Again, it's critical at 65 north because that tends to be where the onset and retreat of glaciations tend to get initiated. Obliquity, precession indices together, so you can see how timescales mix to give you these beats that are a combination of these things. So simulated Greenland temperatures here in terms of the bipolar seesaw again, so Antarctic delta T and Greenland temperatures, associated carbon cycle that we have already talked about, and methane and the differences. So on 100,000 year time scales, they are similar. They are both feedbacks, positive feedbacks to glaciation and deglaciation. But when we zoom into this is a million years. I have to be careful here. Okay, not 100,000 years. Okay, so this is the Vostok ice core record we've been looking at again and again. So on these 100,000 year time scales, the methane and carbon cycles are positive feedbacks and in phase with temperature, with the phase lag, of course, because temperature begins to warm or cool before because of the orbital forcing and so on. I'm just repeating some of these things to put ourselves in the context of where we are. So split Denisovan Neanderthals in Eurasia here more recently, and zooming in 130,000 years ago. Okay, looking again at insolation, I hate this bloody computer. Greenland temperatures and relative sea level that we have looked at various podcasts already in the past, and sea surface temperatures at 45 north in the Atlantic, much more resolved records looking at Heinrich events, Dansker-Dusker events, and so on and so forth, but in the context of Homo neanderthalensis and out of Africa of Homo sapiens. And here is the Chinese composite of the Delta 018 records. So this is the ice rafting debris at 45 north, grains per gram of sediment. So you can see how many evidences can be collected. This is important for getting a picture of regional climate variabilities. So this is the map showing the locations of paleo-environmental records discussed in the text of this paper that I referred to here, and listed in table 1 of the supplementary material. Red circles are pollen records. All these red circles. Black circles are archaeological sites. Gray circles all over here are diatom records, including some should be in the coastal waters, but they can be in regional seas and lakes as well, which give you temperature record also for those periods. Red triangles are less records, again airlifted dust that corresponds to strength of the monsoon, especially in the monsoon regions here, for example. Black triangles are speleothems, so you have some cave records of speleothems, dripping groundwater that leaves climate variability signals. Orange line is the intertropical convergence zone. Green arrows south and north westerlies, so you have wind, so you have monsoonal circulation and westerlies, and blue arrows are the Asian summer monsoon here. Okay, so pulling it all together, I'm just going to kind of give you a sense of the regional climate variability, again keeping in mind our ancestors split Denisovan Neanderthals over Eurasia here. So that's the Siberian cave material. We are looking at marine isotope stages and wet and warm conditions this way. So when you are this way, you are wet and warm. So typically warm tropical temperatures come with higher humidity and rainfall, especially monsoons. When you go down here, it's dry and cool. So corresponding temperate forest pollen from Lake Ohrid at 41 north and 20 east. So you can see wet periods correspond to high pollen loading vegetation booming, and dry cool periods correspond to reduced pollen. And obviously here you have also Antarctic temperatures being shown on this other side. So this period of Neanderthal Denisovan split is corresponding to a warm wet period in terms of pollen record, even though we don't have the Antarctic temperature record for the same period. Okay, here in the winter precipitation in the Mediterranean, forest pollen, wet and warm, and dry and cool. So here you can see again no record found there. Asian monsoon over central China, you can see again corresponds to wet and warm. So there is a consistency in regional climates across various places on the planet. East African monsoon, this is the Afro Mountain forest herb pollen in Lake Magadi, I don't know how it's pronounced. So here you have to be careful because this is dry in this direction and wet. So you can see that there is reduced dryness means more wetness, so it is in some sense consistent even in the savannas and grasslands of East Africa. And this is the mountain forest in the green colors. So the plains and the mountains will have different signals because the rainfall, orographic rain, can be very different. On the plains can be dry, whereas orography may be getting a lot of rain. East African monsoon in East Hardland and mountain forest and eastern woodland pollen, again you have wet this way and various different pollen records combining. So this is a good way to look at what are the consistent signals at low latitudes and high latitudes and across several sites at the same latitude. This is looking at millennial scale paleo-environmental changes in Africa and Eurasia during the last climatic cycle. So we are going here at 135,000 years that we have been focusing on. Without going into detail again, forcing of precession and obliquity recorded in Greenland temperature records shown in that faint gray line there. And looking at iceberg discharge at 45 north corresponding to Heinrich events, you can see corresponding temperate Atlantic forest pollen. So Heinrich events correspond to changes in meridional overturning circulation which affect Eurasian climate very strongly, and they should correspond to temperate Atlantic forest pollen as well. So there are corresponding signals on land because after all the Homo dispersals and migrations and speciations happened on land. Okay, temperate Atlantic forest pollen here at 42 north and 9 west, again corresponding to wet and warm, and the signals of each isotopic stages. So these are the kind of details that are presented with models and all the evidences in the chapter. I have kind of taken a brief route through them without going into the details, but you can see the perturbations in terms of vegetation and also temperature and precipitation, which would have affected habitat suitability, for example. This is the Delta O18 Sorek cave record here, wet and dry. Here you have to be careful which one is which. Mediterranean forest pollen, so again corresponding to, so you get slightly displaced, and some places this signal here is small in temperate Atlantic forest but is large in the Mediterranean forest, for example, because the climates are different, and things like the shift in the ITCZ or the North Atlantic Oscillation, which tend to be associated with meridional overturning, different frequencies, so one has to be careful as well. But Atlantic meridional overturning can be Atlantic multi-decadal oscillation can be part of this as well. This is Namakaru and fine-leaved savanna pollen. This is the iron and calcium in Southeast African margin. So you get the idea that there are multiple land signals in multiple vegetations, in multiple climate bands, latitude bands and longitude bands. This is now going to reconstructed ice sheet expansion during MIS 24 to 20, going back to almost a million years, so 790 kilo years to 928 kilo years. MIS 16 coming closer to 650 kilo years, MIS 12 at 450, MIS3 more into our time scale at 45 kilo years with Homo sapiens, Denisovans, and Neanderthals running around, and the associated extension of the permafrost in lighter blue, that is estimated at an average of 550 kilometer extension towards the south based on the permafrost extension during the last glacial maximum in Europe. So some analogs are used. Again, the point is that all the marine isotope stages have associated reconstructions of permafrost and ice sheet expansions. Ice sheet is basically a definition of a glacier when it gets beyond something like 50,000 square kilometers. So you can see also the corresponding habitats of Denisovan Cave, Lake Baikal, and what else can we identify here? Those are the ones. So you can see how close the ice gets here. The ice sheet and permafrost are far away during MIS3 from the Denisovan Cave, which would seriously affect the vegetation, habitat suitabilities, and so on over all these places. But during MIS12 and 16, you have ice sheets dipping way down past the Denisovan Cave towards the south, which would also change the sea level, temperatures, precipitation, humidity, and so on over here. Also dust amounts, and similarly in this episode. But MIS 20 to 24, going back to 790 kilo year to 928 kilo year, ice sheets retreat far north again, but this region is still glaciated. These regions look very different. So here UK is fully covered. Here large parts of Europe and Eurasia are also covered. So the idea is that glaciations, deglaciations, stadials, interstadials, meridional overturning circulations all created large changes in regional climates as well, which would have played great role in habitat suitability and paths taken, sea level changes associated with those as well, and where they would settle down, and where habitat niches or refugia would force different species to come together, and so on and so forth. So the interglacial glacial cycles here, showing westerlies and so high latitude westerlies in both hemispheres, and the change in ITCZ and the dry and wet climates. So you can see that you would have woodland here and stable zones of forests here. So you have woodlands way up here, desert which expanded during the glacial but shrank during the interglacial. Forest remains almost the same because the rainfall didn't change that much, whereas the southern part of Africa experienced changes in dryness and wetness, Namib Desert and so on here, and there is kind of a refuge here, for example, which remains wet and stable in both glacial and interglacial. So which regions of the planet, especially low latitudes and parts of Africa that got affected by glacials and interglacials, would have greatly affected human migrations and species succession. So this is a representation of the simulated expansion and contraction of the eco-cultural niches of Neanderthals and Homo sapiens in Western Europe, and particularly in the Iberian Peninsula during and glacial interstadials at 8. So GI, so just be careful. Homo sapiens did not reach southern Iberia because of the low animal biomass during HS4, allowing Neanderthals several years of survival in this region. Again, interpretations. With the afforestation of the GI8, Homo sapiens colonized southern Iberia and was in competition for the same ecological niches occupied by Neanderthals, leading to their niche contraction. So this is now getting into more regional details. Heinrich Stadial, HS4, and Greenland interstadial, which I should have been more clear. Greenland interstadial 8. Interstadial is warm, stadial is cold, right? Greenland interstadial, and so interglacial, Greenland interstadial, glacial, and Greenland stadial. Okay? So Homo neanderthalensis and the implied density of animals on which they would have depended, and the ecological niches and open Atlantic forests. So you can see there is Mediterranean woodlands more in these interstadials, whereas during stadials you don't have the Mediterranean climate and the woodlands. They get converted into semi-deserts during cold periods. So you can see the shift in vegetation here, going from ecological niches changing because of the shifts in forests from open Atlantic to steppe. Okay, so all kinds of nice details provided here, along with potential impacts on ecological niches and the megafauna that would have been around as well. Idea is really that regional climates, ecological niches, megafaunal populations, and who dominated obviously changed with climate events like stadials, interstadials, and Greenland interstadial and Greenland stadial and Heinrich events and so on and so forth. So here are the Homo sapiens. You have to see when their habitat niches superposed and when they would have led to either interbreeding or conflicts. Those issues obviously are not as well resolved either. Okay, so I will leave this here, and then we will come back and talk about the end of the glaciation. This is the last figure from this paper, showing again a comparison between paleo-environmental changes in the Western Europe and number of dated archaeological sites by 500 intervals during the last 37,000 C14 years. Due to the uncertain age reservoir of foraminifera-based C14 marine samples, we compare archaeological and marine paleoclimatic records plotted against raw C14 ages. They are not adjusted. Number of dated archaeological sites. B is the Mediterranean forest pollen record from the southwest Iberian margin. So Iberian margin here is critical because that's where the evidence for the earliest presence of modern humans begins to appear. Atlantic temperate forest pollen record from northwest Iberian margin, and finally relative sea level changes as an indicator for ice volume changes and changes in insolation in July at 65 north. So here we have insolation changes at 65 north and relative sea level changes. Obviously low insolation, cold temperatures correspond to cold sea levels, and warm insolations and warm temperatures correspond to high sea levels, and there is a corresponding wet and warm climate and Mediterranean forest pollen records. So you can see all the Greenland interstadials, last glacial maximum. So we are going here from about 40,000 years right up to into the Holocene. So so you have Greenland stadials, Heinrich stadials, and the various marine isotopic stages. Temperate Atlantic pollen. You can see the big jump here towards the end of the last glacial maximum that would have had little bumps along the way during the last glacial period from 135,000 years to the end of the glaciation here around 12,000 years ago. So these are the number of sites that were dated. Okay, so you get the idea. The main point is that the regional climate variability was complicated. Niches opened and closed, and superposition of Neanderthals and Homo sapiens happened based on these climate signals and habitat suitabilities and niches. And the Floresiensis was independently thriving there, and Denisovans also over these periods. So you have to just figure out when the Denisovans went extinct and when the Floresiensis went extinct, and when the Neanderthals and Homo sapiens, and where they coexisted, and whether they coexisted peacefully and interbred or they had conflicts, and so on.